Hi everyone, this is Anvita Bansal, and today the problem that we are going to discuss will be convert array into zigzag fashion. So this is again your SD sheet. You can open this up and let's go and solve this problem. Convert array into zigzag fashion. Okay, so what does this problem say? You are given an array of distinct elements of size n. I'm sure you must have already given a read to this problem. And your task is to rearrange the elements of the array in the zigzag fashion. Now, what do you understand by zigzag fashion? So if you see it here, they have given something like this, which means that whatever the given array is, you have to rearrange it in such a way that you get a peak of the element between the two neighboring elements. What does that mean is that if you this is 4, this is 3, this is 7. So here if you see after 4 the number is 3 which is less than 4. So there is a dip after this number. What do we want? We want a peak in our array. So let me just move to the whiteboard and help you understand this one. Let me write the test case. Have a look here. So 4, 3, 7, 8, 6, 2, 1. What was it? Okay. So this is the given array. This is your given array. And what do you want to return? What you want to return is you need to return it in such a way that whatever your array is, it becomes something like this. It becomes something like this. It can be like this, it can be like this, it can go below. The basic purpose is that there is always a peak of an element between the two neighboring elements. Whatever the peak is, no matter if it's greater than the largest previous value, that doesn't matter. What you want is you want the peak of an element between the two neighboring elements. This is something that you want. So if we were to arrange this array into this fashion, what would it look like? It should look something like this. Starting with what can come to your mind is brute force approach if I talk about. So both the approaches that we will be discussing, it's again just a bit trick and also a little mathematics that's about these problems. Okay, so if I discuss your first approach, it will be something like this. Sort this entire array. Sort this entire array. What will I get? I get 1, 2, 3, 4, 6, 7, 8. Right? If I sort it, I will get something like this. Right? But it is still not of this pattern. If you see, after 1 I'm getting 2, but after 2 I'm getting a number which is again greater than 2, right? It is so sorting will give you an array in the graph. If you see something like this, it is always increasing, right? So we don't want that. What can we do? If you think it off in this way, let's start the iteration from index 1. And in sorted array, the next element is always going to be greater than the previous element. ARR of I plus 1 is always going to be greater than your ARR of I, right? And but what do we want is, for this problem, we want in not in all the cases, in the intermediary cases, I want if I've got one smaller element, right? So the next element, let's say at I index, I want should be greater than the index at ARR of I plus 1, right? So if I start my iteration from first index, you will see I will have the value which is greater than my previous element. So this first condition is satisfied. The element here, let's say ARR of I minus 1, is already smaller than ARR I. But in the sorted array, ARR of, let's say if it was I, ARR of I plus 1 will be greater than ARR of I. So can I do something? Can I swap these two elements? This will become 3. One second. If I swap it, what will I get? This value will become 3. This value will become 2. And do you see one thing? On swapping, always this is ensured that the element at ARR of I minus 1, right, is going to be still less than the value present at ARR of I, that is at this index. Why so? Because after this is a sorted array, and whatever element I find after 1, anyway they are going to be greater than 1. So even if I swap the elements that are after 1 and I swap between them, their positions, anyway that value is going to be greater than 1. So I do not have to worry about ARR of I minus 1 if this is satisfying this peak condition or not, right? So now once I swap it, I am getting a peak like this. This is 1, right? This is 1, this is 3, and then this is 2, right? I'm getting something like this. So it is fine. Now what should be my next iteration? Should I start, not start, should I continue for value at index 2? I don't think so, because set of these three elements is in good state now. Now what I want to assess the array is for value at I is equals to 3. So you see this thing. Now in my array, I have 1 followed by 3 and 2. Now I am at index 4. I was assessing, previously I was at index 1. Now I am calculating for index 3. What will I calculate? Again, I will calculate the same thing. I will do nothing but I plus 2. 1 plus 2 will be index 3, right? So you see this thing, if I swap it with the next element, I'm swapping here ARR of I with ARR of I plus 1. Now if I swap it with 6, what I'm going to get is 6 and 4. And do I have to bother if this swapped value is greater than this value? No. Why? Because any value after index 2 is anyway going to be greater than the value present at index 2, right? So now my iteration will be for I plus 2th index, that is 3 plus 2, 5 index. This, so now my iteration will come at I is equals to 5. I'll do the same thing again, swap the elements 8, 7. So do you see that pattern that we wanted? This is 1, 3, 2. Now what you get is 6. Let me draw it here. This is your 1. This value is 1. Now you get 3. This is 3. Then you get 2. This is 2, right? Now, then you get something which is 6. This is 6. And then you get 4, which is like, let's say here. Then you get something which is 8. This is 8. Then you get 7. So do you see that this pattern which it satisfies? Now what is the time complexity of this approach? If you see, the time complexity of this approach is, first thing is we are sorting the array. Let's say we use the inbuilt sort function in Java, arrays.sort, that takes n log n of time, right? And then we, in one pass, we make the comparisons. So that is O of n. Anyway, this is going to dominate this complexity. So overall complexity will be n log n. Is that fine? Okay. So if you go and try to solve this on editor, it will give you time limit exceeded for bigger test cases. So one thing is that you need to optimize this approach. Okay. So how do you optimize it now? Fine. Have a look here. Before that, let's go and okay. Oh, shit. Let me just clear this up. 437. Now let's discuss the better optimal approach. What can be the better approach here? Can we do it in one pass? Yes, we can. So the little trick here is, let's do one thing. Let's take Boolean flag as true for the case when we will be at the lower left of the peak. This is something that it should look like, right? Let's say when we are at this lower half, let's say our flag is true. And when we are at this portion, let's say our flag is false. And let's understand it, how to solve it. So we will run this loop I0 till what length? See, I'm keeping this empty for now. We will see at what length it should go. Okay. The reason being, see, it should ideally go till what value? This value. You will see why. Okay. So if my flag is true, my flag is true. If it is, means I don't need to even write this. If flag, then what you need to check? If my ARR of, what do you want when your flag is true? I want that this is, let's say, I plus 1 and this is, let's say, ith index. So I will check if, only if this value is not greater than this value. If ARR of I plus 1 is basically less than ARR of I, right? In that case, swap the elements, swap with each other. And also change the value of flag to false. Why? Because the next step we will be calculating would be for this part, right? So put another condition. This is for this. Now, if your flag is false, what are you going to do? Then flag false, according to our calculations, we have set flag 2 in such a way that it will handle this lower half of your peak, and flag false will handle this second half of your peak. So for second half, the condition should be that if your ARR of, let's say in this case, now this is I plus 1. If your ARR of I plus 1, it should ideally be less than ARRI. But let's say if it is greater than your value present at ith index, in that case, you will swap. And then you will change the value of flag to true, which means now the next step, whichever in the iteration would be, that would be for dealing this part of your array. Let's do a dry run. So let's say this is your given array. My flag was true initially. I'm writing my flag here as true. This was true. I am starting my iteration from this index, right? From 0th index. Okay. If flag is true, which is true, then I will see if ARR of I plus 1 is less than ARR I. Yes, that is also true. So swap it. This will become 3. This will become 4. Okay. So now your flag will become false and your iteration will come at this step. Also, it is an else condition. Understand this thing. Either you are dealing with this condition or you are dealing with this condition, not simultaneously dealing with both the conditions. Now, iteration I is at this position. Your flag is false, so you come at second. You come at second case. If flag is false and you check for ARR of I plus 1, it is greater than ARR of I. Yes, that is true. So you swap them again. So this will become 7. This will become 4. Now you iterate for this value. Also simultaneously, your flag becomes true. So make it true now. Okay. Now when you are at this index and your flag is true, you come at this condition. If flag is true, and then you go and check for if ARR of I plus 1 is less than ARR I. No, that is not the case here. You don't swap. You simply change the value of flag to false. Okay. Now you iterate for this value. Flag is false. ARR of I plus 1 is 6. It is greater than ARR of I? No, it is not. You don't swap. You simply change the value of flag, which is true now. Now your iteration is for this index. Now you are at this index. Your flag is true. You come at this condition. Is ARR of I plus 1, which is 2, less than ARR of I? Yes, it is. So you swap it. You swap it, make it 2, make it 6. Okay. And then your flag's value changes to false. Fine. Now you iterate and come at this index. Flag is false, you come at this condition. If ARR of I plus 1, which is 1 here, greater than this value, no, it is not. You won't swap it. You will just change the value of flag to true. Now you are at this index, right? You have already swapped it. Basically, I would like to iterate till n minus 1. Because now whatever it is, I have already swapped with I plus 1th value. I'm making the check for I plus 1. So let's say if the value of n is 3, right? Not 3. Let's say value of n is 1. you are given an array of with index 1. This is zeroth index. So for this case, I equal to 0 is fine, but if I make it I is less than n, let's say n is 0, less than, let me make it n equal to 1, right? So if I do it less than n was what? 1. Currently it is 0. So it will go into this loop, right? I'm just telling you the difference if I use n, or should I use n minus 1. So if my n is 1 and I put this condition I less than n, so I is equals to 0. For I equal to 0, this for loop will execute, right? And it will go and check the condition. Initially my flag will be true, right? So it will compare ARR of I plus 1. I is 0. ARR of I plus 1 will become ARR of 1. So do you have any index 1 here? No. So that will be index out of bounds. Understood? The reason we will not take till n, but we will take less than n minus 1. That is ideally we are reaching till n minus 2th index. This is n minus 1th index. This is n minus 2th index inclusive. Understood? So let's go and solve this problem. Let me see if you guys can see. Whiteboard was not visible. Didn't you see my whiteboard yet? Oh God. Let me show it 1 second. So you ideally have not understood anything because whiteboard was not visible. What do I do now? Okay, let's do one thing. I'll go ahead and solve this problem for now. We might take another lecture in that case because I don't think so recalling everything in this stream would help anyway. Let's go and solve this problem. I might repeat this lecture in a fresh video. Okay, so let's code it here. If you try to follow what I said, maybe you'll understand a bit of what I'm going to write. So I am taking a boolean flag equals to true, right? Then what? Then I am iterating for int I equal to 0, I is less than n minus 1 and I plus plus. Okay. If my flag holds true, if flag is true, for that condition I check if ARR of A of I plus 1, it should ideally be bigger than, greater than I value present at ith index. So if it is less than ARR of I, in that case I will swap it. Swap it using a third variable. In temp is equal to A of I. A of I equals to A of I plus 1. Okay. Then A of I plus 1 equals to temp. Fine. Once you swap it, you change the value to false. Next condition. Else, this if is done, fine. In else case, what you're going to do is, if you check if your A of I plus 1, it should be ideally smaller. So I'll check for greater case and swap it. A of I, if it is greater than A of I, in that case, you will swap it. Fine. And then you change the flag value to this. We did when it was true. This we will do when it will be false. So I will change it to true. And that's all. And you will return it. You don't need to return it. It's void function. without returning, also this will work. I'm honestly feeling very disappointed. My entire explanation went in vain because whiteboard was not visible. So let me move back to the whiteboard. I hope I can help you understand, because I first discussed the brute force approach, which will give you time limit exceeded. Basically, you can try it also. Then we discussed this optimal approach, which we just coded. And I'll just come back to this approach and help you understand what we wrote. So basically, we are iterating over this array from this index to from which index, from index I equal to 0 to n minus 2, inclusive. Okay, inclusive. Now what I'm doing is, I'm in the beginning I'm keeping my boolean flag as true. This I'm doing because, see, what I'm thinking is that I want something like this in the array, a peak like this, right? Let's say this is my I, this is my I, and this is my I plus 1. For example, I'm at this. So for the first half of my peak, let's assume that my flag is always switched to true. And for the other half, lower half, basically this other end of my peak, I am handling it in such a way that my flag will be false. So when my flag is true, I know I'm going to handle a case like this. Okay. So when my flag is true, what I need, I want that whatever value is present at I plus 1, it should be greater than the value present at ith index, right? So if that is not the case, if let's say this is what I find in my first half of this peak, I want it to be, what I want is swap the values. So this is smaller value, this is greater value, so it will make the array look something like this. Smaller value will come here and the bigger value will go there. So if my flag is true, that means I want something like this. In order to get something like this, if it is already not like this, I'm going to check, is arr of I plus 1 less than the value present at this ith index? If it is less, swap it so that I can get the peak here. And also change your flag to false, so that next thing that I will be solving, I'll know that I'm going to solve for the second half of my peak. Okay. Now in this example, when I started my iteration from 0, I'm at fourth index, right? Let me write it fresh here. 4, 3, 7, 8, 6, 2, 1. I start my iteration from 0th index, right? I check my flag is true. My flag is true. My ARR of I plus 1, this is 3. It is less than 4. So I swap it. After swapping, what I get is 3 here. 1 second. After swapping, what I'm going to get is 3 here and 4 here. Okay. Now my iteration will go for this. And here I'm storing the flag values. Initially, it was flag initially was true, right? Now it will become false. Is that clear? For the next iteration. For next iteration, I commit else condition. I check my flag is false. This is flag. This is false. So I check ARR of this was I. I check for this value ARR of I plus 1. It is greater than ARR of I. Yes, it is. I swap it. So after swapping, this will become 7. This will become 4. Right? And my flag becomes true. Okay. Now my iteration, my for loop, this for loop, my iteration goes to the next index. That is for this index. What is the value of flag? It is true. So it will check for ARR of I plus 1, which is 8. 8 is greater than 4. So this condition fails. I'll do nothing. Simply change the value of flag to false and just continue with the next iteration. Now my index is at position 8. For 8, flag is false. I commit this condition and check. ARR of I plus 1 is 6. 6 is less than 8. Here the condition should be, it should be greater than 8, only then you swap. So this doesn't hold true. I just do nothing, no swapping, just simply change the value of flag to true and go to the next iteration. This is the next iteration. Now if flag is true, we go at this condition, right? Now can you see my screen? Let me just check it. I think now you can. Yeah. Now what we were doing, okay, your flag was true, you are at this index, so you will check this condition, I plus 1 is 2, it is less than 6, yes it is, so you swap it, you make it 2, you make it 6, and then your flag becomes false. Fine. For the next iteration, you are here, your flag is false, you check for ARR of I plus 1. It is greater than 6? No, it is not. So that's the end. You also make it true. And for the next iteration, if you go and check, you will see it will exceed the limit. It will be at n minus 1th index, which is not equal to, or which is basically greater than I. Basically I will exceed the boundary, so no loop will execute. And now if you see the state of your array, you will see what do we have in array 3, this is 7, then this is 4, then this is 8, then 2, then 6, then 1. So do you get a peak like this? See, this is 3. Let me draw the peak here. See what we want. Oh god, now what we wanted was, okay, have a look here. Now I'll show you the resultant array, how it looks like. Although I've already discussed it, but while I was discussing, you were not able to see my whiteboard. That is why I'm just going through this again. Okay. So my resultant array is this, right? So if you look at this resultant array's pattern, how will it look like? It will look something like this. This is, let's say, 3. Then it goes till 7. This is 3. This is 7. Then it goes down to 4. This is, let's say, this is 4. Then it goes up till 8. Let's say this is 8. Then it goes down to 2, which is less than even 3. This is, let's say, 2, right? Then it goes up till 6, which will be little less than 7. Less than 7. Let's draw it here. This is 6, let's say. And then you get 1, which is less than even 2. So this is what we wanted. This is what is the basically zigzag pattern of your array, that you are getting the peak between the neighboring elements, right? So this is what we wanted to achieve. We achieved it, and in maximum of on time. So that's how we improve the time complexity from n log n that I already explained to on. If try to solve with that n log n approach also, you will get time limit exceeded. Then you will understand how this case works better. I hope this is clear to you all. Why it is on? Because at max, actually it is on minus 1, but 1 can be discarded here, because when we have a heavier value number, then we can obviously discard the constants. That is why here at max, every element, we are processing every element at max once. We are iterating over the entire array only once. So this is O of n time complexity. So that is all about this problem. See you all tomorrow, right at 6 p.m. with the next lecture. Thank you, everyone.